Hello everyone and welcome to another Math tutorial video. Now I'll be discussing Form 5 Additional Mathematics, Chapter 3 Integration, Long Question Example 1. Okay, before that, please like this video to show your support and subscribe to the channel for more upcoming mathematics tutorial videos in the future. Okay, let me read the question now. The rate of increase of temperature theta degree with respect to time t second is given by d theta over dt is equals to 1 over 2 in a bracket 14 minus t. So for the question part A, they ask us to find the value of t when theta is a maximum. Continue to read the question part B. Given that theta is equals to 25 when t equals to 8, find the maximum value of theta. Okay, so this is the overall question. So I hope that you will attempt this question in the future. If you could manage to solve this question, a big thumbs up to you guys. But if you can't solve this question, no worries, I'm going to show you the step-by-step working and the solutions. So without further delay, let us start to solve the question. Let us begin our discussion for the question part A, where they ask us to find the value of t when theta is a maximum. Okay, so in order to find the value of t when theta is a maximum, we need to set our turning point value, guys. Okay, in the question they already give us that d theta over dt is equals to 1 over 2 in the bracket 14 minus t, close bracket. Okay, let me write over here question part A. So in order for us to set the turning point, okay, so let me write here, set the turning point. So we need to make sure that our d theta over dt is actually equals to 0. Okay, so when we set our d theta over dt is equals to 0, then only we can able to find the point, whether the point is actually maximum or minimum. In this case, it is mentioned that theta gives you a maximum value. Okay, so let us continue with our working over here. So from here, 1 over 2 in a bracket 14 minus t, close bracket, is actually equals to 0. Okay, so the 2 you times with 0 from here, you get 14 minus t is actually equals to 0, and therefore you should get your t is equals to 14 second. Okay, so this is the answer for the question part A, guys. Okay, let me underline the solution. So when time is equals to 14 seconds, so your change of temperature with respect to time will be equals to 0. So during this point, you will have a maximum value of temperature. Okay, so that is the meaning behind this turning point concept, guys. Okay, so let us proceed to the question part B, where they ask us to find the maximum value of theta. Okay, and they already give us the value that theta is equals to 25 when t is equals to 8. Okay, continue our discussion for the question part B. Okay, let me rewrite this equation over here. So from here, given that d theta over dt is equals to 1 over 2 in the bracket 14 minus t, close bracket. So the 1 over 2 you times in, so from here you get d theta over dt is actually equals to 7 minus t over 2. Okay, so in order to get the theta, what we're going to do is we're going to integrate d theta over dt. Okay, so from here let us continue. So from here, theta will be equals to, you integrate d theta over dt with respect to dt. Okay, you perform this, you should get back theta again. So that is the explanation behind this equation, guys. Okay, let me box this in case if you don't know. So when you differentiate theta, you get d theta over dt. So when you integrate d theta over dt, you get back integration. So it's a two-way learning, guys, over here. So from here, let us continue to calculate the theta. So from here, theta is equals to, okay, integral 7 minus t over 2 with respect to dt. Okay, let us perform the integration over here. So from here you should get theta is equals to 7t, okay, minus t square over 2, okay, and then you times with 2 again, so and then you plus with c. Okay, why times with 2? You should remember, guys, 1 over 2, there is a constant over here 2, so that's why you need to times with 2 over here. Okay, let us continue. So the 2 times 2, the denominator you should get 4, so from here your theta is equals to 7t minus t square over 4, okay, and then plus with c. Okay, remember that the question gave us the two information. When theta is equals to 25, okay, you get your time is equals to 8, or given that theta is equals to 25 when t equals to 8, so it can be either way around. Okay, so from here, so when theta is equals to 25, okay, in this case 25 degree, so from here you should get your t is equals to 8 seconds. Okay, so let us substitute this value into the equation here. So from here 25 is equals to 7 times with 8, and then you minus with 8 square over 4, okay, and then you plus with c. Okay, so please wait, guys, let me write the bracket here, so in case if you get confused. Okay, let me move this. Okay, now it's better. So let us continue our discussion. So from here in the left hand side still remain 25, so 7 times 8 you should get is 56. Okay, 8 square you get is 64. 64 divide with 4 you get is 16. So from here 56 will be minus 16, okay, and then you plus with c. So this is for the right hand side. Okay, 56 minus 16 you should get is 40, so you're left with 40 plus c. So to find the c, what you do, the 40 from the right hand side you move it over to the left hand side. So from here you should get c is equals to negative 15. Okay, in this case negative 15 degree, but we just write here negative 15. If you wish to write 15 degree also can. Okay, so let me underline this. So this is just the first step. Let us continue. So once you get this, we write this negative 15 back into the equation here, the official theta equation. So from here theta is equals to 7t minus t square over 4 minus 15. Okay, so now we are almost to the end of the question. So from here, to find the theta max, remember that in order for your temperature to be maximum, your time will be equals to 14 seconds by setting our turning point, guys. Okay, because in the question part A we set our d theta over dt is equal to 0, and from here we get our time is equals to 14. So now what you're going to do is we're going to use this time equals to 14 seconds and substitute into the equation here in order for us to find the maximum temperature. Okay, so from here theta max is equals to 7 times with 14 minus with 14 square over 4, okay, and then you minus with 15. Okay, okay, so you calculate this. So from here you should get your max temperature is equals to 34 degree. So this is your final answer, guys. Okay, let me underline the solution for the question part B. Okay, so that is all for the step-by-step working and solution for this question. I hope you understand the full working that I've shown to you. If you like this video, please give your thumbs up. If you haven't subscribed to the channel, please subscribe to the channel and hit the bell icon for more upcoming mathematics tutorial videos in the future, and not to forget to share this video. Thank you everyone for your support, and I will see you in the next video.